everyone, my name is Gabriel Mendoza, and today I'll be walking through my project, which is a classifier machine learning project that classifies a cappella versus non-a cappella audio clips. Great. So the problem that I'm trying to solve, right? So a cappella is music that doesn't have any instruments, but recognizing it by eye or metadata isn't very straightforward. Generally, music is represented solely by waveform clips, but that doesn't give very much meaning, as you can see on the right. And as a member of the Pitchforks, which is an a cappella group here at Duke University, we often spend a lot of time going through many different audio clips, whether we're looking for music or recording music to find examples, and there's never really a clear distinguishing guideline for us, and we spend a lot of time trying to classify between a cappella and non-a cappella for our own use. So because of this, in order to make our group more efficient in this way, I decided to build my own data set, and as you'll see later, a classifier that works quite well. So what do we have here? The approach was to build this pipeline. I first collected several short audio clips, and I converted each of those to a MEL spectrogram, which is just a visual representation of sound frequencies over time. And then I compressed that into 128 numbers, capturing the frequency profile. And then finally, I trained a classifier that output the predicted label and also the confidence of that prediction. So as I said, I collected my own data, which was 34 total clips, 17 a cappella and 17 non-a cappella. Each clip is between 7 to 15 seconds long, and I recorded and labeled everything myself. This is an example of a MEL spectrogram, as you can see on the right. Time is on the x-axis and the frequency is on the y-axis. This is Eye of the Tiger, if you can tell by the introduction here, and you may be able to guess that yourself. So what were some of the takeaways? The model worked very well with 100% accuracy with the clips that I had. The noise, if you include noise, it dropped it to 83%, which is pretty good nonetheless, and it shows the robustness of the model, but also how noise can decrease the ability of the model to perform well, and then also just the random forest to show that it was not as good as the logistic regression. And on the right side, you can see a PCA curve or PCA graph, which shows a cappella more coalescing together, and then non-a cappella is a lot more spread out as it's a bigger category in general. Nonetheless, without further ado, here is the video. First, I choose a file, which I first choose an a cappella demo. This is just a recording of my group singing. From this, you can see that it's pretty low frequency for the most part, and it obviously classifies it correctly as a cappella with 100% certainty. And then the next one I have is a piano, which also is pretty low frequency, but you can see that it, again, classifies it correct as non-a cappella. And then the last one I choose is Forget You, which is a song that has a lot more variability and a lot more higher frequency as well because it's studio made. Great. So what did I learn and what's future work needs to be done? A key takeaway is that models can classify music as a cappella and non-a cappella with pretty simple features, and that MEL spectrograms is a very great way to represent that data initially from raw waveforms. Future work would be to perform this on larger data sets with other classifications, whether that's different types of music styles or even different instruments, to see if it continues to work on with more information. Great, thank you for listening to my demo.